So one of the more interesting ways to make an alcohol is with the Grignard reagent. The Grignard reagent is formed by a reaction between an alkyl halide and magnesium, and it's characterized by a carbon-magnesium bond that is ionic. Well, what happened to my... It's an ionic bond. And it looks like this. It makes a carbon with a partial negative charge, and it makes it a nucleophile. The carbon becomes a nucleophile and is able to attack a carbonyl group of ketones and aldehydes. So this is what we end up with. We end up with a negative charge here, and that negative charge can form a carbon-carbon bond. So that's why I guess I thought this was the more interesting one. You're not only going to make an alcohol, you're going to make a carbon-carbon bond. So what happens here? Our mechanism, the electrons on that carbon attack the carbonyl carbon here, and these electrons go and live on the oxygen. And let me change back to, so this will have extra electrons and be negatively charged. We have added an R group here. The other R groups are still there. I didn't have them drawn. I was trying to make this simpler. And then we'll have a proton transfer. The electrons from this oxygen are going to, do we have a preference for color? Here we go. We will grab a proton from a neighboring water molecule, and these electrons will go back and live on the hydroxy. And that will produce an alcohol. We'll have our original R groups will still be here. And we have a new R group that's been added to the carbonyl carbon. Okay. So the product is an alcohol and involves the introduction of an R group. Then this is a little summary. A chiral center will be formed if the product is racemic. And here we've got a couple of examples. This is the carbon that gets attacked, and it's the one that gets the methyl added to it. Here, this carbon is attacked, and the methyl is added. This one forms a chiral. This one forms a chiral center, and so it's racemic. Water must be added in a separate second step because the Grignard reagent will deprotonate water. The reaction is very sensitive to water. The Grignard will not attack the carbonyl of a carboxylic acid. So if we have a carboxylic acid, the Grignard reagent will not form. It will attack it'll deprotonate the alcohol. So here we have our carboxylic acid, and what happens is this is our Grignard reagent, and it's going to remove this hydrogen, and so this reaction will not occur. So you can't have the Grignard reaction in the presence of water or even mildly acidic protons like an alcohol. Okay, so let's look at the skill builder. We're going to compare, we're going to prepare this compound. And so the first step will be to identify the carbon that's attached to that hydroxy group. And I'm going to change to here. So this is our alpha carbon. And we've got 3 groups attached to it. We've got a phenol. This is our methyl. And this is our ethyl. And so there are 3 different ways to put this compound together. We can have a ketone that has the phenol and the ethyl on it and add the methyl. Or we can have a ketone that has the phenol and the methyl and add the ethyl. Or we can have a compound that has the methyl and the ethyl and add the phenol. So all three solutions are valid.